Writing a basic shell script is often just stacking commands one after another. It gets the job done, but it is highly fragile. If a single unexpected error occurs, like a missing file or a changed directory, that linear sequence breaks and the entire script collapses. To fix this, we need to introduce structured programming. This means giving your scripts the ability to make decisions based on real-time data and the logic to repeat complex tasks automatically without breaking. We are going to apply these concepts by building a master script from scratch. By the end of this, you will have a fully automated system log manager that creates, inspects, and processes log files entirely on its own. To follow along, you will need 3 things: an open terminal window, a basic text editor, and the foundational knowledge of how to create and save an executable bash file. Moving from linear commands to structured logic changes the script's relationship with the system. Rather than executing blindly, the script now evaluates the environment and reacts to the specific conditions it finds. Step 1 is establishing our script environment. We start with the bash shebang at the top and immediately define our 2 main variables: logdir to set our target folder and max files to limit how many files we generate. We define these at the top because hard-coding file paths directly inside your logic blocks is a maintenance nightmare. If you ever need to change the destination, variables give you a single, centralized point of control. Next, we need a way to maintain clean code when the script talks back to us. For this, we create a modular function called logEvent. Its entire job is to intercept our terminal outputs and format them consistently. In this logEvent function block, variables $1 and $2 capture the arguments passed to it. Notice the local keyword. You must use this inside a function's scope to prevent global variable pollution, which accidentally overwrites data elsewhere. By routing our text through this single function, we replaced repetitive, messy echo commands with a unified, professional logging system that accurately timestamps every action. Now we introduce logic. Our first requirement is that the script must check if our target log directory actually exists before it attempts to write any files into it. This if statement block evaluates our directory structure, creating the folder only if missing. Notice the double brackets for this test. In modern bash, explicitly mandate this shell syntax, as it handles empty strings and spaces better than the older method. Checking our common test operators reference, the -d operator specifically checks if a directory exists. By placing the exclamation point, the logical not operator, in front of it, we are telling the script to execute the next line only if the directory does not exist. These conditional statements allow the script to verify the system state, preventing the execution of destructive or redundant commands. Next, we need to generate data. This code block shows a for loop. A for loop is the correct tool for definite iteration when you have a predefined specific number of actions to take. Here, it reliably generates our exact limit of log files. Section 3 transitions to a while loop for indefinite iteration. It processes files repeatedly as long as our condition remains true. Inside, a nested if statement pauses each cycle, using the -f operator to verify it's a regular file before processing. Warning tone. But indefinite loops carry a massive risk. If the condition you set is never met, the loop will run forever. An infinite loop consumes your CPU, overheats the process, and requires forced termination of the program. The mechanical fix is simple but critical. At the bottom of our loop, we explicitly increment our counter variable by 1. This guarantees the count will eventually exceed our maximum file limit, safely terminating the loop. Loops leverage the script's execution speed. Because of this structure, your script can process 3 files or 3,000 files using the exact same code footprint. With the logic complete, save your file. Run the chodmod +x command to grant executable permissions and trigger your script in the terminal. Looking at the terminal output, we can see the system working exactly as designed. The script verifies and creates the directory, iterates through the file generation, and returns a clean, perfectly formatted timestamp for every action. This summary table covers the core concepts we just used. You can see the distinct purposes for conditional logic with if, definite iteration with for, and indefinite repetition with while. The final rows cover our structural elements. Functions give us code reuse, and the $sign numeric variables allow us to pass dynamic arguments into those functions. The structures we've used, logic, loops, and functions, provide the mechanical framework for scaling your operations. By writing code that makes its own decisions,